This one, we're taking two limits. One's going to positive infinity, one's to negative infinity of a function with a square root. It's a little bit interesting. Let's bring down part A here. Now, when we take the limit as x goes to infinity of a fraction, let me just write this. Yeah, let me do part A. Let me just write the general game plan. What do? We grab, oops, yeah, grab only the highest power term, grab only the highest power term top and bottom, numerator and denominator, because that's all that matters. I've shown this in some other videos, right? So in other words, I'm going to get rid of this guy, and get rid of this guy, and get rid of this guy, and get rid of this guy. Why? Because on the top, 6x squared is way more powerful than 11. On the bottom, 2x is a higher power than just 4. So you just grab the highest power term, top and bottom. That's all that matters. Why? Because we're going to infinity. If we're going to just 2 or 3 or negative 3 or whatever, then yeah, they would all play an important role. But if you're going out to infinity, you're plugging in like a million, a billion, a trillion, you're going out to infinity, then plugging in here a million squared times 6 and then add 11, that's nothing. A million squared is actually a trillion times 6, that's 6 trillion. So if you have a $6 trillion debt and then you add 11 bucks, nobody cares. 11 is nothing compared to the 6 trillion, right? Same thing down here. We're plugging in a million, billion, trillion. So we plug in a billion here, 2 billion, add 4, the 4 is nothing. Remember, we're going to infinity. A billion and trillion are just the beginning of that. So all that matters is the most powerful term on the top line. If you want to know where it's going, that's what we want to know. Limit is where you headed, right? So, all right. So with that in mind, let's take part A. And so this becomes a limit as x goes to infinity of this, oops, come on, square root. There we go. Square root of 6x squared over 2x. I just totally get rid of those other guys. They don't matter since we're going to infinity. Okay, now what's that? Well, that's um, the limit. Let me separate the thing here. Let me separate. What I'm going to do is I'm going to go separate 6 and separate x. You don't have to, but I think that'll make it more clear. It's going to separate those. You don't have to, but I just want to show you something. Okay, so now, what is the square root of x squared? Now, I know you're probably thinking, like I thought as well when I was taking calculus for the first time. I thought, well, it's x. I know that. I've seen that, right? I've done it before. It's not my first time. So this is just x, and then the bottom is 2x. Well, no, that's actually not true. You know what it is actually? It's actually the absolute value of x. Now, let's pause right there. That's the most important point of this example. What is? That the square root of x squared is equal to the absolute value of x, not just x, not just x. And that'll change some answers. Why? Let's prove that. I want that just to be something Mr. Heron says. I want you to see that's true. You're going to go forward to math and science. It's all about truth. What is true? Why is that true? Well, take square root of x squared, and let's just plug something in. Let's plug in x is negative 3. See what we get. Well, we'll get square root of negative 3 squared. Right, which is what? Square root of 9, which is what? 3. So you see what it did? We put in negative 3, and what did we get out? Positive 3. See, it made it positive. Do you see that? It's because that second power right there makes it positive. So it actually makes it positive, which is what? Which is absolute value, right? It gets rid of the square, right? So it squares it, making it positive, and then the root gets rid of the square. So in the end, it's absolute value. It makes it positive. So it's important you know that. Okay, so now where are we at? Now we can plug in our infinity. Bringing this down now. This is just a little proof. that really it's absolute value. That proves that the square root of x squared is actually absolute value of x. Anyway, so then we got over here. Let's wrap up this problem now. So the square root of 6, and then we're going to plug in infinity right here and infinity right there. Um, oh, wait a minute. I'm probably being a little bit confusing. Basically, yeah, well, I am. I'm going to go 2 times infinity. Um, these can cancel. I know I've said before infinities can't cancel, but they're both just x to the first power. So they are going at the same rate, so we can cancel them. So our answer is the square root of 6 over 2. If this was like x squared or x cubed, and this was just x to the first power, then you can't cancel because they'd be going at a different rate. But I am canceling those, and the answer is square root of 6 over 2, which, if you do the decimal, is this right here. Either way, you can type in square root of 6 over 2 or the decimal. Now, I want to show you so the second part, you might say the second part's the same. Well, but we're going to negative infinity. So what's that going to do? Well, let's bring it right to here. So it's going to be the limit x goes to negative infinity of what? Well, I'm going to just jump down to basically right where we're at the end there, right? All these steps, you start with that, simplify it to that, make that absolute value. That's all the same. We get to here now. It's time to plug in the infinity. So let's plug in the infinity. So we get absolute value of infinity over 2. Oh, sorry, we're plugging in negative infinity. Let's try again. Absolute value of negative infinity over 2 times negative infinity. So what's going to happen? These are going to, we're going to get on the top positive square root of 6 times infinity over negative 2 times infinity, right? Because on the top it's absolute value, so it makes it positive, doesn't it? Now these cancel because they're both infinities to the first power, if you know what I mean. They're infinities to the first power, so the same level, they cancel. But now it's positive over negative, so the answer is negative root 6 over 2. So it's the same as the last answer, but it comes out negative. Why? Because it's absolute value on the top. And so when you plug in the negative infinity on the top, it stays positive, but the one on the bottom is just a regular x, so it's negative, and positive over negative is negative. So that's why it's negative, the same answer as the other one. So that's how that works. The main moral of the story is, remember, square root of x squared is not just x, it's absolute value of x. And so that's going to make that negative infinity positive on the top. The one on the bottom is just a regular x, so it stays negative. Positive over negative is negative. And there we go.